Hello everyone, welcome back to my channel, that is at CURIOCHEMISTry. So we are going to understand about how oxygen is showing double bonds. Okay, so on the screen you can see I have already written all the details about the oxygen. Okay, due to some like technical issues I'm not able to write in during the class, so before before the class I only prepared for that. So okay, so let's continue. So oxygen has atomic number 8 and we can write that as 2 comma 6. Okay, 2 comma 6. So as we know that for any element, for it showing its reactivity and also the stability, it should be having the 8 electrons in its last orbit. Okay, so you can see here, this is the molecular structure of the oxygen, right? So, and this P and N shows that P means proton, N means neutron. Okay, and in the first shell you can see here, first shell 2 electrons are there, and in the last shell that will be 6 electrons. So, in the oxygen at the outermost shell, how many electrons are? That is 6 electrons. Okay, and we can easily figure out by looking at the molecular structure and even by the electronic configuration for some of the elements we can say that. But we know that it should be complete the octet rule. It should be shows that 8 electrons in its last orbit, and whenever in the last orbit how many electrons are present, that it shows the element's valency. So according to this, from this structure you can see how many electron needs for the oxygen, that is 2 electrons. It need 2 electrons to complete the octet. So he same like hydrogen and carbon, oxygen is not losing or gaining the electrons, but it shares the electrons with the similar atom of it, that is oxygen. So this is oxygen 1 and this is oxygen 2. Okay, if you observe properly to this diagram, you can see that 2 electrons are sharing to the another atom. So here how many electrons are sharing? 2 electrons are sharing. So by sharing these 2 electrons, we can show again by the use of dot and cross method. Okay, I have not used here crosses, I just used here dots only. So how many electrons are there in the total in one oxygen? That is 8 electrons now. So we can write the electronic configuration, that is 2 8 like this. So, and how it happens? By sharing the electrons, by sharing the electrons. So whenever the electrons are sharing by the elements from by the atoms to get the stability or just to follow the octet rule, so that type of compounds are said to be covalent compounds. Okay, covalent compounds. Fine. So here also you can see little bit this part, when how we can understand that here is the single bond and here is the double bond. So whenever you see this is one electron and this is another electron, when they combine they form one single bond. Okay, but here we have two electrons, so simply it shows double bond. That's why we write oxygen by showing the double bond like this. Okay, and for hydrogen we write like this, single bond. That's why this is the reason behind that whenever we are writing oxygen, okay, in the word we write like this, but when you show the symbol we are not showing like this only. This is only oxygen atom, but whenever we are showing like O2, that is a molecule, and this O2 means it's showing its diatomic structure, diatomic property, because to get the stability it needs one more oxygen. Okay, so it is showing the diatomic properties. Similarly with the chlorine also we are writing Cl2, not Cl. This is only a one chlorine atom, and whenever you are showing the molecular form we have to write in a molecular form, that is a diatomic form, that is Cl2 or oxygen, that is O2. Hello everyone, welcome back to CURIOCHEMISTRY again. Yes, we are talking about nitrogen today. Yes, so nitrogen is a diatomic molecule which has the atomic number, that is 7. You can see on the screen already written is already it is written, right? So it shows the electronic configuration 2 comma 5. So we know that it needs how many electrons? 3 electrons. Very good. So we need 3 electrons to complete the nitrogen's outermost shell. So what it will do? It will do just that is the sharing one, which already done by oxygen and chlorine also, right? So what nitrogen will do? It shares the 3 electrons to another nitrogen atom and forms the triple bond. You can see on the screen it forms the triple bond, and from this cross structure you can see one nitrogen is sharing 3 electrons and another nitrogen is sharing 3 electrons, and they form like that 3 bonds, that is triple bonds. Okay, so from this information what we are collecting this information for drawing the other compounds. Okay, to structure we can draw the structure by, if you know about the single bond, double bond and triple bond, you can draw any structure. So here we are drawing ammonia, structure of ammonia has one nitrogen and three hydrogen atoms. So simply we already knew now that nitrogen is showing that is triple bond. So simply draw draw three bonds and then connect with the hydrogen atoms. Okay, so after that the much awaited, let's talk about the carbon compound, and we took the example that is methane one. So from the name only you can see that methane has carbon and hydrogen. Okay, and we know that carbon shows 4 valency, that means it needs 4 electrons to complete its octet, and hydrogen shows 1 valency, that it needs 1 electron. So here carbon will be share the its 4 electrons to other 4 hydrogen and become stable. So on this structure you can understand that carbon is sharing 4 electrons to 4 another hydrogens. So that's why it becomes CH4. So what we will understand from these examples? We are understanding that here these compounds are not losing or gaining the electron, they are just sharing the electrons, and this type of sharing of electron is said to be forming the covalent bonds. Okay, it's said to be covalent bonding. So these covalently bonded molecules are seen to have strong bonds. Okay, they have strong bonds in these molecules, but the intermolecular forces are small, means that much not strong as compared to these molecules are strong, but the intermolecular force is not that much strong, like how we can see in the ionic compounds. Okay, that's why they are having low melting point and low boiling point. Okay, so since the electrons are shared between the atoms, and that's why they does not shows the any charged particles. Okay, that means they are not showing any ions here, how we can see in the ionic compounds. That is the difference. Okay, so such covalent compounds also are, they are poor conductors of electricity. We already discussed about this. Fine. So that's it for today. We will meet you in next video. Thanks for watching.